Okay, perfect. So hello again, everyone, and I'm excited to be here with you today to give you a small introduction about AI design and development. So as you have mentioned, my name is Zena, and I'm a GDSC lead at LAU, and I'm a GDG organizer, and I'm also a machine learning facilitator with Google Crowdsource. So you can always connect with me on LinkedIn or message me on my email in case you have any questions after today's session. So let's get started. So what to expect from today's workshop. So today you are going to learn more about building your own neural networks and getting started with machine learning. It will be a bit interactive. So you are going to write some code actually and build your own neural network. So you'll be working a bit on Google Colab, which we'll be explaining in a bit. And the second part of this session is about how to interact with users and how can we understand and calibrate trust whenever users are using our machine learning applications, since you know that all of the ideas that users have about machine learning and the ethical things behind it. So we are going to also discuss these. So here's the agenda for today. We are going to, as I said, train some neural networks, and then we'll be discussing the human-centered AI and calibrating trust, displaying model confidence, and at the end, we'll have a small Q&A session. So before we start, I would like to know more about you. So share with us some of your background in the chat. So are you a developer, data scientist, product manager? So what exactly are your interests or background or even experience in this field? So you can type in the chat and I'll be reading your comments just to know who are our audience for today. So Karim said he's a biologist, data science, full stack developer, computer and communication engineering. And please share with us if this is your first session or you don't have any experience in machine learning or even a little bit of experience in machine learning. So do you have an experience in machine learning, or is this your first time attending a workshop? So developer, computer scientist, so first time, biomedical engineering. Okay, so since we have some first-timers here, I would like to extend my warm introduction to those having their first machine learning session today. You are taking a really good step if you are interested in this field. And by the end of this session, you'll actually be training a neural network. So this is a really good thing, a really good introduction to get started in this field. Okay, so thank you all for sharing about your experience. And let's move on. So we have just saw what are your roles in this field. So it's time to talk about the roles of AI designers or AI developers. So what exactly do we do in the field? So the field that you are currently seeing on the screen is a figure that we will be showing you over and over in this session, because it's really all what machine learning is about. So we have 3 steps. The first one is training data, building models, and then generating predictions. So we'll be going into deeper details about each one of these in the coming slides. But I'd just like to know, to note something here, that you can see that it's after the 3rd step, there's an arrow leading you back to the 1st step. And this is actually a really important concept in machine learning, because it's a never-ending process. So whenever you train your data, you build your model, and then you generate predictions, it's not the end here, because you have to go back to the 1st step and retrain your data, get new data that based on users' feedback or based on how your model is prediction once your model is performing once you launch it to industry. So it's really an iterative process. Whenever you reach to the end, you really have to go back to the beginning and start all over again. So since we are humans as AI designers, we also intentionally and unintentionally shape every phase of machine learning. So we also have some human perception at every stage. And this is really important, because as we previously saw in this field, the first step is training data. So we as AI developers, we choose the data sources that we want. And this is a really important step in machine learning. And for me, I consider it the most important, or one of the most important steps when building a model, because as you know, machine learning is all about data. So the main source of how our features or how our models are learning is from data. So if you don't have the correct type of data, or if you do not clean or pre-process your data in the correct way, you will really not be, or you really be wasting your time in the other steps, because without a correct foundation or correct data sources, the other steps are not really will be generating inaccurate predictions or will not be of a big um, useful part of the process. So it's really all about getting the data and getting the correct sources of data. And this usually takes a lot of time whenever you are working with problems in industry or real world problems, because choosing the data is not really as easy as just getting, for example, cats and dogs pictures from the internet. It's really about collecting data based on the specific use case that you want and knowing how to choose them correctly. So this is sometimes can be time consuming, and sometimes it might be also hard to find the correct sources of data, or you'll be even building your own data set in some cases. So once we have the data and once we collect it, label it, and process it, the next step is about building the model. So we have to now decide, okay, so what model do I want to begin with? And sometimes we try more than one model in order to, at the end, land at the model that we will be going with at the end. So, and this is also somewhat time-consuming, because you have to try different models, you have to test it, you have to see if it's generating an accurate prediction, or can you perform better if you choose another model. And we evaluate it based on evaluation metrics, which we'll be seeing in the coming slides too. So a third step is generating predictions. So now we have models and we have data, and now it's time to start generating predictions and see how our model is performing in industry. So after we generate predictions and we got a model that is somewhat performing well and is having a high accuracy, we can now start launching it to industry and start feeding it some new data that it has never seen before, and see how it's performing, or whether we need to go back to the first step, collect another data or add new data to the source that we have, and retrain the model. So this is all about the overview of how machine learning works in industry. Okay, so let's get started now with some code. But before we do so, let me give you a small overview of the different fields of machine learning. So we have always, or you might sometimes hear about AI, machine learning, deep learning, but what's the difference between them exactly, and are they all the same? Because some people confuse AI with machine learning, with deep learning, and some people might also think that they are all the same thing. However, let me clear this concept for you a bit. So as you can see in the small figure on top, AI is the biggest field that we have, in which is all about AI. And within AI, we have machine learning, which itself has within it deep learning. So deep learning, which we'll be focusing on in this presentation, because we'll be working with neural networks, and neural networks is all about deep learning. So deep learning is a subfield of machine learning, and you will be training models using neural networks, as I said, and it works best for unstructured data. So what do I mean by unstructured data? It's data that does not really have a specific structure, so it's like images, text, sound. So you can see here that deep learning is a subfield of machine learning, which is itself a subfield of AI. So now it's time to see the Collab file that we'll be working on for today. So let me just send you the link on the chat, and I just want you to go over the link now and just make sure that you all have it open, and then we can continue throughout the slides. And as I explain every concept, we will be going over and applying it in the Collab file that we'll be currently working on. So I sent you the link. Okay, so I see Karim had a question. So they use classification report and confusion metrics when you make predictions. So these are actually ways to test your model and see how it's performing. So it's actually like an evaluating your model. So we don't really use them to make predictions. We use them to evaluate the model that we will use to make predictions. So let me know if the notebook is open for you, so we can proceed. And later on, I'll also be sharing my screen while we are running the code there. But for now, okay, where's the link? Let me just send it. Okay, all good. Okay, so I think we can move on. Okay, perfect. Okay, so what is Collab? So what you have currently opened from the link is called Google Collab. It's usually a notebook that allows you to run the code instantly. And we usually use it for data science and machine learning because we can run the code using cells, and we can see the immediate outcome after we run every cell. So it's really useful whenever you are exploring your data, you're, for example, plotting figures, training models, etc. So we will be using Collab for this session today. So let's start by explaining you a bit about Collab. So let me just share my screen or just move here to the tab. So this is the Collab notebook that we have. And as you can see here, we have so here we have cells. So every one of these is cells. So here, these are just text cells, and we have also code cells. So this is a code, a cell that has actually code. You can run it by either clicking on this, which says run cell. So you can run it from here, or you can just let me just. Okay, so it's taking some time. So you can either run it by clicking on this button that runs the cell. Okay, so I have run it using this button, or you can just go into the cell and click or click Shift Enter. So you can directly run it and move to the next cell. So these are two ways of running cells in Collab Notebook. So if you want, you can try it. So you can have, so it can be easier for you to run the machine learning code later on. Okay, so up we have things like file, edit, view, insert, runtime. So what we really want to do now is click on runtime and go to change runtime type, and then make sure that it's GPU and click save. So let me explain to you why are we doing this, because GPU or training machine learning usually takes lots of complexity inside our machine. So changing the runtime to GPU allows us to perform such complex tasks easier, and even prevent some problems from happening if we just relied on our CPU. So you can again go to runtime, change runtime type, make sure that it's GPU, and click save. So let me know whenever you are done from this step, so we can continue the slides. Okay, done. Done. Is Collab better than Jupyter? So they both give you like the same result. I prefer to use Collab, but it all depends on you, because Jupyter you mainly need to use Anaconda, and then from Anaconda you go to the notebook. So I see that Collab is can be sometimes like easier to use. However, it's totally up to you. Okay, so I think we can continue now. Okay, so we have enabled GPU, and let's see about intro to TensorFlow and neural networks. So currently we'll start with the content for today about machine learning, like the, we can say the more dense content about machine learning. Okay, so you might have heard about TensorFlow before. So what is TensorFlow? TensorFlow is an open source deep learning framework. So you always have TensorFlow or PyTorch if you are used to PyTorch. These are two different deep learning or machine learning frameworks, and we'll be focusing now on TensorFlow. So TensorFlow, as I said, is an open source framework that allows us to perform some machine learning work. It's a Python library that has a C++ backend. And usually we write code in Python, but you can also write code in JavaScript using TensorFlow.js. And interestingly, TensorFlow has close to 2,000 people who have contributed code from outside Google. So this is really interesting. And so why do we use TensorFlow? TensorFlow allows us to import some libraries that makes our lives easier. So instead of going into deep details of mathematical details behind building neural networks, like doing back propagation, forward propagation, and all of these complicated things that we will be seeing some of them in the coming slides, TensorFlow has built-in libraries that we can just import and use directly. So it just makes our lives easier, as I said. Okay, so let's start with the first step. If you remember correctly, this figure that I showed you in the beginning, the first step is all about data. So currently we are in the first step of importing the data set. So luckily, and as you might have expected from this training, we have the data set ready and prepared, labeled, cleaned, everything is done for us. So because we won't really have time to build a data set ourselves or even like clean it or pre-process it. So we have data set ready, and we'll be importing it in the coming slide. But before we start importing it using the Collab, let me just tell you more about the dataset that we'll be using for today and what are we doing, what are we building a model for. So the dataset that we are using is called the MNIST dataset, and it's called the Hello World of Computer Vision. So it has 60,000 images that is used in training and 10,000 images in test. And each image is of size 28 by 28 pixels and times 1, which is basically the color channels. So since they are only black and white or grayscale, it's times 1. In this data set, you will find digits ranging from 0 to 9. And what we'll be doing today is training a neural network to classify digits. So by the end of today's workshop, you will have a model that whenever you input to it a number, you'll have a prediction for what the model thinks this number is. So let's start to import the data. So you can go to the Collab that I have shared before. And if you did not run this cell yet, please make sure to run it so you can import TensorFlow. So we are here importing the TensorFlow as I have mentioned previously. And we use as TF. So later on, whenever we want to reference TensorFlow, we can just use TF instead of writing TensorFlow. So next, we need to import some other libraries. We need to import Keras, and we need to import matplotlib, which we'll be using to plot figures. And now here's the part where we are importing our data. So we are importing a data set, which is called the MNIST data set. And we are getting this data set from Keras. So this data set is already present in Keras. So we are just loading it from there. And let me know if you are following it, and if you imported your data set, so we can just make sure that everyone is has the code working. Done. Okay, perfect. Okay, so we just imported our data set. And next, we want to see what is the size of the data set, or what's the shape of each image that we have. And to do so, we can just print the 10 images that we have imported here, dot shape. So this will give us the shape of our data set. So we have 60,000 pictures, and each image is of size 28 by 28 pixels. And let's see if the test images have the same shape. What do you think? Do you think that the test images have the same shape, or do you think that they have different shape? And if whatever you choose, let me know which field you think will change now whenever we run the next cell. Do you think it's the 60,000 or the 28 or 28? So different number. What do you mean by different number? Do you mean the size, or do you mean the 60,000? So which number do you think will be different here? 10,000. So this is exactly the answer. So here it's 10,000, and as you might have guessed, we have 10,000 pictures instead of 60,000, and this is why we have 10,000 here. In the test training images, we have 60,000. So basically, we have all our data consisting of 70,000 images. We have 60,000 for training. So after we train our model on these 60,000 images, we will be using the 10,000 for testing to test if our model is performing well or not. So why do we really need to split groups? Why don't we use the training images and then test our model using the training images too? And this is because the training images, our model has already seen them. So our model has been trained on these 60,000 images. So it will not really make sense to use the same images to test our model, because our model has already learned from these images and has already seen them before. So whenever we test our model, it has to be images that it has never seen before. And this is why we tested using 10,000 new images to see if it's performing well or not. So here we can just see the labels of our images. So each image is labeled. And since we are working with digits, it will be labeled from 0 to 9. So here you can see just a bit of the labels that we have. Okay, so we just imported the data. So is training samples always greater than the testing samples? Do we always like take training more? Yes, so this is usually the case. There usually is the concept of going for 20% testing and 80% training. And this is because you really need lots of data to train on, because the model, like you're building model from scratch. So you need to have data so the model can learn. And then you can have like a bit of images or 20% to just evaluate and test your model. Okay, so let me know if you have finished the importing the data set, so we can proceed with the pre-processing. So what do you think about the problem of RAM in Google Colab? So sometimes if you're talking about the RAM here, so sometimes you're working with large amounts of data, and the things really get really complex that the RAM here gets full, and the Collab will just close and tell you to restart, and this rarely happens. However, if you are working with huge and complex data, this might be a problem. However, it rarely happens. Okay, it's done. Okay, so we just imported the data set. So let's now normalize it. And by normalizing, I mean that to make them all within a certain range. So we know that images has pixels. And since since each pixel is between 0 and 255 because of the RGB concept, we need to divide every pixel that we have by 255. So at the end, our images will be consisting of pixels ranging between 0 and 1. And this is helpful when training our models, so it can work on images of the same range. So after we normalize our data set, we can plot some images from the training set. And currently, we are plotting the first 25 images. So this will show us what our data looks like. So as you can see here, we have digits ranging from 0 to 9, and they are handwritten digits, so they are written by hand. Okay, so by that, you will be done from the data part. So let me know if it's working for you. I'm facing a name error. So Hanan, can you give us more details about the name error? I think it might be that you forgot to import some library up. So if you can go up here to importing, and you make sure that you run this cell to import TensorFlow, and you imported all of the other libraries in the other cells. Okay, so let's move on. Okay, so you just imported the data set, and you also saw how to pre-process it and display some images from the data set that we have. However, a bit like I want to throw here some bad news that it's not as easy as what we just did. And as you would expect, working with real data is a lot more complex than this, because we need to collect data from scratch. We need to label it, clean it, pre-process it. So it's really we have to do everything from the beginning. So. And even if we don't want to create our own data set, searching for the data set online that is free, open source, and it has what we need it can be somewhat difficult. So, and we are currently living in the world that we are progressing a lot with data. So somewhat data can be lacking. But I think that currently in the upcoming period, we'll be having lots of data sources or lots of concentration on data. So after we finished, we can now start creating the neural network. But before we start going to the code and training or building a neural network, let me first give you some concepts about neural networks. So what exactly is neural network and deep learning? So deep learning is a subfield of machine learning, and it involves writing and training neural networks. So neural networks are one of the more advanced areas of machine learning. So as we saw previously in the small 3 subcircles inside each other, we saw that machine learning has inside it deep learning. So it's one of the more advanced areas of the machine learning. And it usually takes a long time to become really comfortable with using neural networks and building them. So it's totally okay if you'll see some of the upcoming concepts a little bit complex. We will not go into lots of details, but even though with that, you might feel that the topics that we'll be discussing are a bit complex, and it's totally fine. So you're not expected to understand what's happening in the upcoming slides. However, I hope that it will all be clear for you, because we will not go into more details, and I'll try to simplify it as much as possible. So we said neural networks, and as you might guess, neural networks are composed of neurons. So what is a neuron? A neuron is a basic building block of any neural network, and it is a binary classifier. And by binary classifier, it means that it takes data as inputs and returns a yes or no answer as an output. So as you see here in this figure, you have on the left, the x's are the inputs. So for example, if you were training the data or model on images that we are currently doing in the Collab, the x's correspond to the pixel values from the image. So you'll be inputting pixel values from the image. And then you'll be taking each x and multiply it with something that we call theta, and which corresponds to the weight. So we'll be multiplying with weight. We'll be multiplying them with weights, and weights are initially randomly put. So you initially initialize them randomly, and then the model will learn and adjust them using a gradient descent, which we'll be talking about it in the coming slide. And then a neuron takes a linear combination of the weights and inputs to produce a score. So you could say that, for example, if you got a score that's positive, you can say that the image is a cat, and likewise, if you got a score that's negative, you can say that the image is a dog. And sometimes, which is sometimes optionally, you can apply an activation, which we call G. Sometimes it's like sigmoid, so it's a squashing function that you can see here, and it's done to normalize the slide, normalize the score between 0 and 1. So you'll be having at the end an output that's between 0 and 1, and this is really important whenever we are later evaluating our model, because some loss functions require you to have this done, and it's also good for our neural networks to be trained on such data. So let's see another view of a neuron. So here's another diagram of a neuron that you can see on the left. So we see an image, and within this image, we can see pixel values. And I would like to note here that we usually have 3 values for each pixel, which represents the RGB. But here, for simplicity, we have only like drawn one value inside every pixel. So as you can see here on the right, also the image has been unrolled into the array X. And this is the input of our neuron. And the W shows the weights. So these are initialized randomly and then trained with gradient descent, as we have previously mentioned. And the neuron produces a score by taking the dot product of the inputs and the weights. And as you can see on the top right, you can see that it's our neuron is beginning to look a lot like a small neural network. So however, this is not really a neural network, because in order to do so, we need to add another layer. So now we have 2 neurons that you can see with blue and the light brown. And if you look on the top right, it's beginning to look a little bit more like a neural network. And to classify an image, our neuron now does a matrix multiply. So it takes the matrix and it does a matrix multiply to classify an image. So, and here is where the GPU comes more into benefit, because GPUs are popular in deep learning because they are very fast at multiplying matrices. So this is also one of the reasons that we use GPU whenever we are training our neural network. So here's another view with the code that corresponds to it below. So you can see that this is the model that we'll be writing now in the beginning. And it consists of a single dense layer with 10 neurons that takes an unrolled image as the input. So this is not a neural network yet, as we will have to add another dense layer for that, and we'll be doing that soon. But on top, you can see the unrolled pixels from the mnth digit that's connected by 10 neurons. And the lines that you can see here represent the learned weights that we have talked about in the previous slides. And here you can see the code that corresponds to building this layer. And we'll be doing that in the Collab soon. So, so a layer returns a list of scores, but instead of the list of scores, we really want probabilities or list of probabilities of our predictions. And since we'll be using these predictions to classify an image, so the prediction that has the highest probability will be what our image actually is. So that's why we need to actually have probabilities and not the list of scores that currently our neural network up till now gives us. So for that, we use something called softmax. And softmax is a piece of math that does that, you can say. And we really won't dive into lots of details about softmax today, because it's a little bit more complex than this. But you can think about it as something or a piece of math that returns a list of probabilities. Because as we mentioned before, we need a list of probabilities and not really the list of scores. So here, as you have noticed, so here we went from this to this. So as you might have guessed, we added another layer, and we will have a neural network by that. And the layer here is called a hidden layer, because it's like within two, like we have here the softmax, and here we have a hidden layer within it. And this is the code that corresponds to adding another layer. And as you might see here, we really just added another layer of neural network with just one line. And this is also what's really interesting about TensorFlow. It allowed us to just add another layer of neural network with just one line of code. So all hidden layers have to include a nonlinear activation function. And the default activation function is called ReLU. And you usually don't need to change this. So you just keep it as ReLU. And each layer is a matrix multiply. So without this activation function, a series of matrix multiplies reduces into one. So the hidden layers won't be able to learn any new patterns. So we need to have this activation layer here. And as I mentioned, it's usually a ReLU, and you don't change this. So here we, so as we saw here, so we just add another dense layer, and it consists of 10 neurons that takes an unrolled image as an input, as we have previously mentioned in the previous slides. And up till now, it's really not a neural network yet, because we have to add another dense layer that we will see in the upcoming slide. And instead, what we currently have is called a multi-class logistic regression. So this is not a neural network so far. And on top right, or on top here, you can see that we have what we have been seeing before as unrolled image of pixels. So here you can see that they are connected to 10 neurons, and the lines here represent the weights that we have previously talked about. So so before we start training our model in Collab, and I hope that wasn't too complex, let me just go over a bit about how do we evaluate the model that we got. So now we will be adding some neural networks as we discussed, and we'll be training the model on them. However, how do we know if what we got is satisfying results, or how do we know what is the accuracy of our model? And this is what we'll be currently discussing in the upcoming slides. So we have something called the optimizers. So you remember when I told you that the weights are randomly initialized, and then as the model trains, it will adjust them. So I told you that we'll be talking about gradient descent in the upcoming slides, and we have reached this part. So gradient descent is what our model used to adjust the weight that it has learned, and it sometimes uses something called backpropagation to adjust these weights. And we'll adjust the weights step by step, and then we'll be using gradient descent and optimizer to do so. So after we optimize the weights, we need to see what is our loss function, or how to evaluate our model. So for that, we can either do it using, we have something called loss, and for every machine learning model or use case that we want, we have a different loss that we can use. So for example, if you are classifying categories that we are currently doing, because you can consider each digit as a separate category. So you have category of 0, category 1, category 2, and so on. So we are currently doing what we call categorical classification. So for that use case, we need to use something called sparse categorical cross entropy, because this is what the loss function that corresponds to our use case that we currently have. So if you want to understand the loss function in simpler terms, you can think about it as just a fancy word for error. So you can evaluate the error of your model using a loss function. And if you want to understand like in a simpler way, also you can also think about it, or think about understanding it using a logistic regression, or what we currently have, or what we call, for example, a regression. Because in regression, we use something called mean squared error to evaluate our model. And the mean squared error is basically just a matter of difference and square. So for example, if you are building a model to have a house prediction, so you are training your model on seeing some house prices, and then you wanted at the end to see a house, or to see the features of a house and tell you what is its predicted price. So for that, we use what we call regression, because we'll be having like a series of features or house prices, and we want to see how it progresses over time. So we have like a series of or sequence of points. So for that, we use a regression. But what I want you to just understand from this example is how do we use loss here, or how is loss calculated in regression. And I mentioned regression here because it's really a simpler, it has a simple loss function than what we usually have in other categories or other use cases of machine learning. So if you want to evaluate the loss of a regression, let's say you have a house of that has a price of $50,000, and your model predicted that its price is $500,000. However, its true price is $480,000. So how is loss calculated over here? It's just having the difference between 500,000 and 480,000 and just squaring it. So this is how the loss is calculated in regression. And the other parts of machine learning, like categorical classification and the other parts, follow a similar concept, however, with different loss functions or different calculations for the loss functions. So I hope it's the loss function or the loss idea is clear for you now, because we'll be using it in the Collab file. So the last thing that I want to discuss is training our model. So we'll be using the fit method on our model that we created, and inside you can see that okay, we are taking the training set and the X train and the Y train, which corresponds to our training set and the labels, and then we are using something called epochs. So what is an epoch? An epoch is how frequent or how many times does our model go over the training set that we have. So for example, if we have 5 epochs, this means that our model will go over the data set that we have, or the training data set that we have 5 times to update its weight. And generally, the longer that we, or the higher the number of epochs, or the longer that we train our model, the more accurate it will get. However, if we chose a really large number, or if we trained it for so long, we will be falling into another problem which is called overfitting, which means that our model knows really well about the data that we have. However, it cannot really generalize it to data that it has not seen before, and we do not want to go into this problem. So we just choose a good amount of epochs that we might see it's good for our use case. Okay, so it's time to go for our Collab file and create the layers or create the neural network. So you can go over. To your Collab file and run this cell. And in this cell, we are building a sequential. We're using the sequential from Keras to flatten and to create a flatten and dense layer. And we are using the softmax activation as we have mentioned. We are adding 10 neurons, and the input shape for us is 28 by 28 because this is the shape of our images that we have. So next, we want to compile our model. So we are using an Adam optimizer. We are using, as we mentioned, the sparse categorical cross entropy as our loss function, and we are also evaluating it using the accuracy as metrics. And next, we are choosing 10 epochs for now. So our model will now be running for 10 times. So here it's epoch 1 out of 10, and then it will be 2 out of 10, and so on till 10 out of 10. So our model is actually being trained over here. We are using the train images, the train labels, and the number of epochs. So till our model finishes, and this is actually like, if you might see that this actually takes time. This is actually a really fast overview of a model being trained. Sometimes the model takes hours and hours to get trained, and just going over the epochs. So this can be a bit of time-consuming part of training a machine learning model. So till it's done, let me know if you are able to run all the cells in your Collab so far, or if you're facing any problems. So if you have any questions, also let me know. Yes, Karim, sure, you can contact me at any time. Yes, the recording will be shared with you. Thank you, Mahideen, for sharing this series. I actually do not know it, but I'm sure that it's a good source. Okay, done. Everything is good. So, Noor, I did not really get your question, but the Collab has a built-in GPU. So if you run, for example, NVIDIA on your Collab, you'll see that it has a built-in GPU that allows you. So in case you do not have GPU installed on your laptop, you can still use the GPU in the Collab. However, it has a limit. So unless you get the premium version. So the more epochs, the better results will, and more time it needs. Yes, so as I mentioned, the more the epochs, the better the results. However, until you reach overfitting, so you actually do not also want to train it for too many epochs, because you'll be overfitting your model. So you'll have to choose the good number of epochs that you want to train your model on. Okay, so the accuracy is 92%. Yes, so I got here 93, as you can see here, it's 93% as an accuracy. You might also be getting a different result. So it's not that all of you will be getting the 93%. And here we can use you can see the loss function too. Okay, so finally we will be evaluating our model. So now we will be feeding it the test images and test labels. So we can see how well it performs on data that has never seen before. So here the test accuracy is 92%. So here what we saw before is the training accuracy, and here what we are really interested in is the test accuracy. And actually, Karim, I just saw that you mentioned the test accuracy. Yes, it is 92%. And here we have, as I mentioned, the loss function and the test accuracy. So this is what we are usually interested in. So finally, let's make some predictions. So we can just run the model to predict a new image. And we can see what our model predicted. So our model will be showing us here that the different predictions that it has. And in order to get what our model is, like the highest prediction that our model predicted, we can just run the next cell that gives us the argmax, or the highest prediction that we have. And here we can see that it's 7. So by that, we have trained a neural network. We have run it to generate a prediction, and you have a fully trained neural network. You can experiment with it by adding other cells here. You can just go here and add a code cell, and you can just test with other images and see how well your model performs. And also, as an exercise, you have here till the rest of this Collab, you have a lot of exercises that you can use. So you can just here play with them, run the codes, and finish the exercises. They are really good things to do in case you are interested in machine learning. So by that, we have generated the predictions, and we have seen how our model performs on the data and the accuracy that we got, the loss function that we got. So I hope that you benefited from this part, because now we'll be moving on to the next part of our session for today, which is the human-centered AI, which is all about learning how to interact with our users and how can we help users trust or calibrate the good amount of trust that we need from users to put into our AI technologies or solutions. And so what we have seen so far is this. So I hope that this looks familiar to you right now. It's basically neural networks. And what we'll currently be doing, we'll be going from this to this. So you see that how the complexity, or how like the image of the complexity really moved from between neural networks to our end product, which is, in this case, you can say that this is, for example, an Android app that allows you to generate predictions on your surroundings. So, for example, you have an app that whenever you show it anything from your surrounding, it will give you what it thinks this object is. So we have seen machine learning and AI and deep learning and lots of things around us. So I'm sure that you have, for example, used a browser before where you saw that it recommended for you a few things. So what is actually happening behind the scenes is all about machine learning. And we have also seen it in autonomous cars, where we will have lots of machine learning solutions built within the car to give it additional features. And it's really important for product creators or designers to understand the role that they play in making users feel in control of technology, because we do not want the other way around to happen. So, and this is one aspect that we call the HCAI, and it's especially given the general misconceptions about the public has around what AI is. We really need to pay attention to this part of AI, or how do we calibrate trust for our users whenever they are using AI solutions. And this is why the PAIR team has put together a lot of resources to help you learn about the users and AI design. And one of these is the People Plus AI Guidebook, which has been just launched in May 2019 in the Google I/O. And within this book, you have lots of exercises or lots of chapters that allow you to understand your users more. And it's actually an open source framework that can help you learn more or know how to make AI product decisions. So you can just go to pair.withgoogle.com to learn more about it or to see it. Because as I mentioned, it has lots of chapters. So it has 6 chapters, as you can see in the screen. But what we'll be really focusing on in this session is the explainability and trust chapter, because we don't have time to go over all the chapters. So we'll be just focusing on this chapter for now. So within this chapter, we'll be talking about explainability and trust, which is all about making decisions based on the prediction of your model. Because generally, whenever users are using our models, they are using it to make decisions at the end. So we really want to help them calibrate the correct amount of trust whenever they decide or make the decision based on our model outcome. So to get started, let me introduce to you 2 concepts or 2 questions that you should ask yourself whenever you are dealing with explainability and trust. The first one is, how much should the user trust the AI system? We do not want the user to under-trust it or to over-trust it. So we want to calibrate the correct amount of trust that the user should have, and we'll be explaining more about it in the coming slide. And you can see here that the second question has been grayed out, and this is because we won't have time to go over it. So it is explained more in the the People Plus AI book that I showed you. So you can just, if you're interested, you can go there and read more about it. However, we will also be explaining the third question, which is, how should we show users the confidence associated with an AI prediction? So we want to make a decision whether or not to tell the user of our model confidence, and I'll be telling you more about it in the coming slides as well. So let's start with the first question. So the first question was, how much should the user trust the AI system? And in order to answer this question, let me tell you a bit about the trust spectrum. So as you can see in the figure on the screen, there are 3 parts of this spectrum. On one end, you have the no trust, and this is when the user really does not trust what your AI model has just predicted and completely ignores it. And on the other end, on the right, you can see the too much trust, and this is when the user has so much trust in the AI product that you gave them, and this can be quite misleading, because it really trusts the AI too much that no longer is a good thing to do. So you really want to calibrate trust for the user in the correct amount, so they do not really under trusted or over trusted. So we want the correct amount of trust. And in order to know more about calibrating trust or allowing the user to trust our products in the correct amount in order to make decisions later on, we need to know a bit about 3 important concepts. So the first one is our stakes. So what are stakes? And to answer this question, I want you to imagine 2 different scenarios. So for example, if we have an AI-driven navigation app that tells us how much time does it take for us to do our daily trip from here to work, for example. And for that use of our model, we don't really want to display like how the time is actually calculated behind the scenes or what's actually happening, because it's something that the user is doing on daily basis. However, on the other hand, imagine that you are using an application that tells you what is the best, let's say, route to take whenever you are traveling by plane. And for that use case, we want sometimes tell the user that, for example, the times are being calculated per hour only, and other details, because it's sometimes this is something that the user does not do every day. So traveling by plane is not something that the user does every day, and this is why we need to sometimes display for the user that the data is being refreshed only per hour, and other details about how the destination is actually calculated behind the scenes. So the next question is about what system data are impacting trust in this situation. And this is and for this question, I want you to imagine another scenario. So let's say we have an application that is a music recommendation app that tells the user or recommends music to the user, and we claim that our app provides or is suitable for all music lovers. And this might sometimes be misleading because when training our model, if you remember in the previous slides, using the data that we train our models on might not include, for example, a specific category of music. So later on, whenever our model predicts the data that it has never seen before, it will not be able to classify it based on the category that it has never seen before because it wasn't trained on. So in that case, we cannot really say that our model is really good for all the music lovers. And another example is, for example, you have, let's say, an application that tells the user or reminds the user to do something. So whenever the user used our application for the first time, our application told the user that you have to agree on terms and conditions in order to proceed using our application. And the user just agreed on the terms and conditions and continued using our application. So one day, this application reminded the user that based on the events that they have on the calendar, the application told them that you need to get ready or you need to leave your house now in order to reach your certain appointment on time. And in that moment, our user got a little bit scary of how is the app knowing about my data? How is it knowing that I have an appointment if it's on a different calendar? And if the user did not remember that they actually agreed on the terms and conditions in the beginning of our application, and within these terms and conditions, we actually asked the user to agree that we track their data. The user might sometimes get scared of how the app is tracking their data. And for this reason, it's also a responsibility for us to allow to remind the user of the data sources that we are using in our application. And we also have to have an option in our settings, for example, to allow the user to opt out of this tracking, so the user can just cancel or just stop this feature of tracking or collecting its data around from the user. So we have to have this option in our application. And the third one is what user knowledge is impacting trust in this situation. And this is all about understanding our end users or how well our users know in technology. So for example, people who are really experts in this field might think that, okay, this prediction is not really well, or they might know how to assess the prediction that the model is making. However, users who don't have any experience in this field might overtrust our application or might react differently to the other users. Like they will not really be able to assess how well our prediction is or our AI model is performing, and they might overtrust our prediction. And this is why also knowing the users that are dealing with our application and knowing how to or how this is impacting trust in this situation is also a really important part. So we talked about the 3 different questions, and now it's time to talk a little bit about displaying model confidence. So if you remember in the beginning, in the previous slides, we talked that there are 2 different parts of the AI design. The first one is calibrating the correct amount of trust. And we have went over the 3 questions that we need to ask ourselves whenever we are dealing or understanding this part. And now it's more about displaying the model confidence. So what exactly do I mean by confidence or model confidence? So confidence is a statistical measure of how a certain prediction or outcome is. So our model will have a certain confidence of whenever it's making a prediction. So for example, if it predicted a picture as a cat or a dog, it might be able to tell us that, okay, this is, for example, 80% confident that this is a cat and not a dog. And sometimes it's, or in most times, it's we have to make a decision here whether or not we tell the user of the confidence that our AI model is predicting. So do we tell the user that that our model thinks that it's that this picture is 80% cat, or do we just not show the confidence to the user? And in order to answer this question, you need to think about lots of different cases. And some reasons of deciding why not to show the confidence to the users is, for example, if the confidence does not really impact the user or does not really help the user make a decision at the end. So if the confidence is not really useful to our user, we might as well not show it at all. And this is because showing it in this case might cause some confusions for the user. So for example, the user might be confused of of how do they evaluate. So for example, if we told them that we have a confidence of 85.8%, let's say, the user might be confused. Okay, so what do I do with the 85.8%? Is it good? Is it bad? And how do I compare it, for example, with the 87%? And what do I go from here? So it might cause some confusions for the user if we displayed confidence when we shouldn't really do it. And it might also cause the users to mistrust our model, especially if they are not really into technology. So if they do not really know into lots of technical details, they might be misled by the confidence that they are seeing on the screen. So this is why we need to understand our users and our use case and judge it based on that, whether we need to display confidence or not. So if we decide at the end to display a confidence, there are 4 different ways that we can display confidence in. So first we have the categorical, NBEST, numeric, and data viz, and we'll be going over each one of them in the upcoming slides. So starting with the categorical, as you might guess, it's about displaying different categories. So here is an example that we got from Gboard, which tells us that the one in the middle, or the prediction in the middle, is the one that has the best match, or the one that the model is most confident about. And then on the sides, you can see the predictions that the model did not really have that much confidence in. So in that case, we have 3 different categories that we can classify our prediction in. It's either a best match, good match, or low match. And based on your use case, you might want to discuss with, for example, your designers, or do some research, or evaluate what your users want at the end, in order to see what categories do you want to go with, and how many categories do you want. So this is a decision that you might want to do in the beginning and in the end of building your AI model, because they are interconnected together. So the second part of, or the second type of displaying model confidence is through the NBEST. And this means displaying a certain number of the best predictions that your model got. So for example, you can see here Google Translate. So whenever we want to translate a word, we can see that the model has displayed only one word in blue box, and then it has alternate predictions down. And this is an example of NBEST, because it's telling us that this word that we have here is the word that our model is most confident about. And then underneath it, we have some other words that the model might think it has somewhat a good amount of confidence. However, the first one is the highest confidence that our model has. So in this case, it's really useful for the users to know which one has the highest confidence, and what are the alternate translations that this word might correspond in. And in case you're thinking about the details that are happening behind the scenes, or whenever you are training our neural network, it's really not complex to do that, because for example, in the model that we just trained, the model already gave us predictions of the highest prediction, and then we used the argmax to see which one is the highest prediction. So we actually have a rank of the predictions that the model gave us. So it's only a matter of translating this into design and incorporating it in our solution, or in our software. So the third one is the numeric, and this is all about displaying a certain percentage that you can see here of how confident our model is. Now, this is one of the most challenging types of displaying model confidence, because giving the users a specific number of an accuracy or of a confidence might be quite challenging if your users do not really know machine learning. Because, for example, they might not know how to interpret a 95%, for example, confidence, or they might not be able to understand if the model like that is performing well or not. And more specifically, for example, we know that any AI model cannot reach 100% accuracy. So, for example, if you are using a solution that gave you a model confidence of 97%, and you are sure that for example, you played a specific song many times that it should be 100% confidence, you might feel a little bit confused, or you might mistrust the application, because if you don't really have a strong background in this field, you might not be able to interpret the results as I mentioned. Now, the last one is called data viz, and it's all about displaying the confidence in charts. As we see here on the right, we have a visualization for the predictions of whether or not any kind of diabetic disease the user is having by displaying a graph here of the different severity grades. So this is also another type of how we might display model confidence to our users. So overall, we have seen these different 4 different parts, and judging whether or not you should go with a certain type over the other one is really all about understanding your users, how the users are going to use your application at the end. You might also want to discuss this with your designer, or even try to think about it before building your model, because it's also connected with building certain neural networks or going with a specific approach. So it's something that you should really assess overall before you start building your model. So in order to have a small exercise over here to see if you have understood the concepts or not, I want you to answer in the chat. Imagine that you are building an image classifier to help your users to identify a specific breed of a dog. So what confidence design pattern might be most useful for your users? So what do you think, or how do you think you should go about choosing a specific type of model confidence? And then after I see your answers in the chat, I'm going to tell you or to show you how Google Lens team actually went and chose one of these 4 specific types. So let's see what will you choose. So Hiddin said he will choose the categorical. So it's really all about just based on your judgment. So there's not really a correct or wrong answer. We're just going to see what do you think, and then you are going to see what Google Lens team thought about this. So unbest, categorical, data viz, numeric. So you just said all the 4 different types. So you, as you saw, like each one might see a different perspective of this problem. So you said categorical, numeric. Okay, so let's see what Google Lens team thought about it. So they chose the MBEST to display the type that they think their animal or the dog has, like the breed that the model is most confident about. And then after it has lots of other different predictions that are of lower confidence than what is displayed at the top. Okay, so as a recap, consider how the stakes, system data, and user knowledge calibrate trust. And you also need to make sure that to set aside lots of time to test it and to see when and how does showing model confidence is beneficial for your users or not. So as I mentioned previously, you can also go to your Collab file and continue the exercises, which includes the fashion MNIST, the cats versus dogs. So these are really good exercises to play around with your neural networks. And in case you want to learn more, you can check out the People Plus AI Guide and the TensorFlow tutorials, as well as a really nice book called Hands-on Machine Learning with Skykit. And this is a really a good book that I really highly recommend you read if you want to learn more about machine learning. It's really useful. And you can also read the paper, which is Why Should I Trust You? And this is also a really nice GitHub repo and a paper that you can read. Okay, so that was it. Thank you all for joining us today, and I hope you benefited from this session and you learned more about neural networks. And if you have any more questions, please let me know, and I'll be here with you to answer any questions over the chat, or even if you want to unmute and ask it, I'd be also happy to listen to you. You're welcome.
Thank you, Zena, for this workshop and for sharing with us all these resources.
You're welcome.
I guess you got some questions in the chat.
Okay, so what's the difference between machine learning engineer and data scientist? So a lot of people confuse between these, and these are actually 2 different parts of the field. So you can be a data scientist where you analyze data, or you have the data that's ready, and you just see what type of data that you have, and you do some pre-processing, you plot graphs, and you do some statistical things on it. and you have the machine learning engineer who actually uses this data in order to build a model at the end and train the model on the data that they got from the data scientists. So these are two different parts, and actually a machine learning engineer can also pre-process the data that they have before feeding it into their model. So these are interconnected, but they are somewhat unrelated to each other. How do you advise someone coming from a different field, for example, electrical engineering, to switch to AI and machine learning? So you really do not need to have any background in computer science, like not a lot of background in computer science. If you want, you can get started with the book that I showed you here. This is how I actually started. I did not really have any background in computer science when I read it, and it was actually really, really beneficial. So if you want, I can send the link over here, as well as the other links. So let me just send it. And there's actually a survey that you can fill based on this workshop. So I'll also be sending it on the chat. Okay, so this is the book, and this is the survey that you can fill. Okay, so another question, what's the best approach to master machine learning? Is it by doing projects or by mastering the tools or studying math? So it's really a combination of both. You cannot understand what's happening behind the scenes without understanding the math or the concepts behind it, and you cannot build new models without like training or building or practicing on building models. So you really have to do both. You do not have to know all of the math behind the machine learning because we have libraries. However, it's really nice if you are able to understand the concepts, because it helps you build the new models in the correct way. So later on, when you start building models that has a specific use case or new data or more complex models, you need to understand how to put the neural networks together, how to build them, and this all comes from understanding what's happening behind the scenes and the math behind it. How to estimate the best number of epochs for our models. So this really happens with practice. So if for more experienced users, they might just directly test a number, and they see it gave them a good accuracy level. However, it's usually a hyperparameter that we changed, and by hyperparameter I mean the parameters that we usually do not settle on a specific one from the beginning. We could just keep testing them and see which one performs better. And we see if our model overfits, for example, we need to train on less epochs and we need to change other hyperparameters. So it's usually all around testing different ones and seeing which one is the best. You were a little bit fast. Yeah, I'm sorry if I went over some concepts fast, and I'm also sorry if I talked a little bit fast, because I usually talk a little bit fast, and if I went over some concepts fast, they were a little bit more complex. So I hope you were able to understand the overview of it. And again, you are not expected to know all about it from this workshop, because it's usually more complex than that, and you need to have like a step-by-step whenever you are learning machine learning. So this was just an overview that can help you introduce you to the two different topics of AI, which are the AI design and building your neural networks. Okay, do you have any more questions? Can you share with us your LinkedIn URL? Yes, sure. So here you go. Okay, do you have any more questions?
Thank you again, Zena.
You're welcome.
بعد حدا عنده أي سؤال لزينة before ending؟ and choosing our winner.